Hello everyone, welcome or welcome back again to another video tutorial from the AP3X Institute of Mathematics Education. My name is Akin, your math instructor, and in today's video we're going to have a very elaborate discussion on a topic which you all know as simultaneous equation. This is probably one of the most challenging topics for students at the secondary level. So my aim and objective in this video is to give you a comprehensive review. In fact, I'm going to be going through almost every inch of possible scenarios that can possibly that you can possibly encounter when you approach a simultaneous equation at the secondary level. Now, of course, I'm going to be walking you through the different steps that you have to follow. I'm going to be walking you through the different methods of actually solving this type of equation. I'm definitely going to be breaking this video up into part 1 and part 2, and I'm going to be providing you with links to useful websites where you can find practice questions to get up to speed with this topic. Alright, now of course primarily I do offer contents for CSEC, CCSLC, SEA, ED, Excel and IG CSE students that are doing exams right across the Caribbean and across the world. So my contents here are not limited to just the Caribbean students, although they are mainly my focus. But of course, you will find valuable and useful information here in this and many of my other videos. So of course, if this is the first time here on the channel, do me a favor, of course, by subscribing to the channel, leaving some positive questions and comments down below. Leave a like if you find value from what you've gained from this video and the previous video. And of course, do not forget to share this out to your mathematics communities. Alright, so let's get into today's video and get into solving simultaneous equations. Now, of course, traditionally, I've always started off with just an explanation of the concept of simultaneous equations. And simultaneous equation runs very deep. Not going to be going into the history of simultaneous equation. We're just going to be going into the methods of solving the actual equation. Now it says here that a pair of simultaneous equations, otherwise called a system of equations, are a set of equations with two or more unknown values or two or more unknown variables. Now, for you to solve a pair of simultaneous equations, you have to first be able to recognize when you're looking at a simultaneous equation and almost when a simultaneous equation is deriving itself. Now, the general form that you're going to find a pair of simultaneous equation written in is in fact this formation here, ax plus by equal p, and we have cx plus dy equal q, where basically the a, b, c, d, p and q are constants. They're going to be numerical values, which you're going to be seeing in the examples in this video. So x and y are basically the repetitive constants. There's an x here, there's an x here, there's a y here, there's a y here. But notice that a, b, c, d, p and q are just random variables placed in the equation, which represents different numbers, negative and positive, fractions and decimals. Alright, now there are 3 methods in which you're going to be exposed to in these series of videos in how to solve a pair of simultaneous equation. Of course, method 1 is what is known as the elimination method. Method 2 is what is known as the substitution method. And later on, as in future tutorial or later tutorial, we're going to be talking about the graphical method of solving simultaneous equation. Now, the elimination method is the most common method of solving a simultaneous equation when you have 2 or more unknown variables. Now in part 2, I'm going to have a very elaborate discussion about the connection between the substitution method and the elimination method. When is the substitution method best to use as opposed to using the elimination method? Because of course the elimination method has limitations. once it becomes a certain type of equation, or once the equations begin to cross-reference, then the elimination method is no longer applicable. So we're going to be diving on into that in in the next video. Now let's dive on then into the elimination method. Now, what is the basic objective of this method? It says here that the objective of this method is to basically eliminate, that is, remove one of the variable, whether x and y, or the equation could be in A or B, or it could be in the form P and Q. The aim is to eliminate one of the variable in order for you to solve for the other variable. Remember, the elimination method suggests that we have two variables that we are solving for at the same time, but one must be eliminated in order to find the other. So therefore, once we have obtained the value of the other, then after obtaining that value, you're then going to be required to replace that value in either of the two initial equations given to you. That's the overall objective, to eliminate one variable, to find the other, and when you find that value, you're going to substitute that value into any of the other two equations to find the next unknown variable. Now, I particularly follow a series of steps that guides me to getting my answer effectively and in a reasonable time frame. Once I do these little methods here, these are the steps. Most of these steps are more mental. It is less calculation. Now, the prerequisite skills required for solving simultaneous equation is base knowledge in solving a linear equation. That is the prerequisite skills that's needed. So if you want to catch up on your solving linear equations, you can see the link pinned in the comments or in the description box below. You will find links to my series of solving linear equations videos. So check that out, and then of course you can return to this. If you have those prerequisite skills down, then you can therefore then go ahead and diving off into these steps. Now, step one is, the very first thing that I do is that I tend to give my equations a name. Equation 1, equation 2. Now, step 2 here is that it's a decision making. Now, I have to make a decision as to which variable do I want to eliminate. Do I want to eliminate the x variable, or do I want to eliminate the y variable? Now, once you're able to make a decision as to which variable you wish to eliminate, then your task is to make the coefficients of the variables that were not eliminated, to make the coefficients of the variables that you wish to eliminate the same. Now, how do we actually make them the same? I will demonstrate in the examples coming up. Now, once you get the coefficients of the variables you wish to eliminate equal, then you have to now check to see, are the signs of those variables the same, or are the signs different? Now, if the signs are the same, then you are going to subtract to eliminate. However, if the signs are different, you are going to add to eliminate. You're going to be adding equation 1 to equation 2 if the signs are different, or you're going to be subtracting equation 2 from equation 1 if the signs are the same. And then once you've done that, you most likely are going to end up with a very simple linear equation, to which we have had elaborate discussion on in my previous set of tutorials on solving linear equations. So you're always going to get an equation with one unknown variable to solve. Once you've solved that equation, you'd have already obtained the value of the first unknown. Then you're going to be substituting that value in either equation 1 or 2 to find the value of the second unknown. All right, so that's a whole mouthful of information. Sounds difficult, but in a moment you'll see how easy these steps are, how these steps actually are. All right, so let's dive on into it then. I'm going to be walking you through a series of progressive examples. These examples are going to be building up as we go along. I'm going to be starting off quite simple, just getting you accustomed to the idea of same signs, different signs, equating coefficients, example one. And as we go along, I'm going to get to a point in this video where you find a very challenging simultaneous equation question. Not very familiar, not very common, but you may encounter situations like this in the near future. So here are some examples of the application process. Now, very first question here is that says that we should solve the pair of simultaneous equation for x and y. Okay, and so the very first thing here that you need to do is in fact give your equations a name. So I tend to do this thing here where I draw a line and I call this equation 1, and here I call this equation 2. All right, so once I've named my equation, I now need to make, as it says here in step 2, it says select a variable that you wish to eliminate, and then your aim is to make the coefficients equal. Now for this example, I don't really need to make any of the coefficients equal. Can you guess why? Yes, you are correct. The coefficients are already equal. So I can skip step 2 and head straight into step 3. Because occasionally you're going to get questions where the coefficients are already equal. So you don't need to make them equal. So since they're already equal, then according to step 3 here, step 3 says that if the signs of the equalized terms are the same, then we must subtract to eliminate the variable. But if the signs are different, or it says here, or otherwise, we must add. So if you check this question out, you'll recognize that the signs here are in fact different. So therefore, that simply means that we're going to be adding equation 1 to equation 2. So therefore we're going to say equation 1 plus equation 2 will eventually become 7x plus 2x is 9x. Obviously when we add 2y to the inverse of 2y, it's going to become 0. And then of course 17 plus 1 is in fact 18. Now you can see here you end up with a very simple equation here that you have to split the product. So by splitting the product here, we're going to divide both sides by 9, and you will find here that x works out easily to be 2. So that's our first unknown value. Now if you go back here to step 4 and we check it out here, it says that we're going to solve the equation for the first unknown, which we just did. We just learned that x is equal to 2. But once we've found that value, we're then going to substitute the value in either of the first 2 equations to find the value of the second variable. So I have equation 1 and 2 up here. I'm then going to make a statement. And this statement is not mandatory, but I like making this statement where I write, say here, sub the value 2 for x in equation 1 or 2. Now, it doesn't matter whether you use equation 1 or equation 2. I particularly always seem to go for the equation that has the smallest value, and I always tend to go for the equation where I can avoid the negative. Now, since 7, 2, and 17 is a little bit bigger than 2x minus 2y equal 1, I'm tempted to use equation 2 here. But you can use equation 1 and let me know in the comments if it is that you have in fact got the same answer as I did. So then wherever I see an x, I'm going to replace the x with a 2. So that becomes then, therefore, becomes 2 times 2 minus 2y is equal to 1. So 2 times 2 is 4. 4 minus 2y equals 1. I remember this is prerequisite skill that is needed for this. You would have already seen how I've elaborately explained to you how do I deal with situations like this. Then you'll find here that I'm going to be tempted to bring the negative 2 over to the right side because I particularly prefer when my subject is positive. So 4, I'm going to transpose the 1 to the left. I'm going to get negative 1. And then I'm going to transpose, say here, the minus 2 to the right. And I'm going to get positive 2y. Alright? So therefore then, I end up here with 4 take away 1 is in fact 3. And that is 2y. So now, here, starting off, I'm going to be dividing both sides here by 2. Because 2 splitting the product between the 2 and the y. So that's 3 over 2 is equal to y. And then that becomes my final solution. Alright, so starting out there with a nice little example, getting a fraction for our answer and the whole number, no problems there. We're good to go. Alright, let's move on then into example number 2. Now you're going to find traditionally that many instructors will instruct you to always eliminate the middle variable. And there's a real mental reason why we ask you to do that, because of course different levels of students pay attention to different details. So when we want you to get accustomed to the rules and the steps and the concept of simultaneous equation, we keep your focus right here in the middle. So that once we keep your focus here in the middle, you're always going to be paying attention to these signs. But is there a case where you have to eliminate the y variable? Not necessarily. You can actually eliminate the x. Because as you can see here in this equation, x plus 3y equal 24 and x minus 2y equal 4. You'll recognize that here we could make 3 and 2 become the same number. Like for example, say here make 3 and 2 become 6. But if you look carefully here, that there's a 1 that is in front of this x, and there's a 1 that is also in front of this x. I already have one set of my variables the same. Let me just go ahead then and name my equations first of all. And then step 2 says I need to select a variable that I wish to equalize and eliminate. I already have my, say here, variable equalized, 1, 1. So if the signs are the same, I'm going to subtract. If the signs are different, I'm going to add. And here's where many students get caught. Their focus is on the signs that are in the middle, when in fact, the focus should be on the signs that are in front of the variables that have the equal coefficients. So in this case, I can't focus on the plus and the minus here because I have not equalized the y variable. I have chosen to equalize, or to say here, the variables that are currently equalized are in fact the x. So the signs of the x's are in fact the same. So this suggests then that I'm going to be subtracting the variable. So I'm going to subtract, say here, here, and here. So I'm going to say equation 1 minus equation 2. Equation 1 minus equation 2. And that's suggesting that x take away x is in fact 0. And then we have here 3 take away negative 2. 3 take away negative 2 becomes 3 plus 2. So that's going to become 5y. And then of course, say here 24 take away 4 is in fact 20. So then we end up nicely here by splitting the product. We end up with, say here, y is equal to 20 divided by 5. So therefore we end up with y being equal to 4. Very simple. Now we're not done, because of course we need to find the value of x. So then by finding the value of x here, we need to end up substituting the value of 4 for y in either of the first two equations. That is either equation 1 or equation 2. So again, particularly, I like working with small numbers. I'm again going to be using equation 2 here. All right. So therefore then, Anywhere I see a letter y, I'm going to replace the y with 4. So I'm going to end up then with, say here, in equation 2, let me just write my statement. I'm going to sub, say here, 4 for y in equation 2. So therefore then I end up with, say here, x minus 2 multiplied by, say here, 4. And then that's going to be equal to 4. All right. And so x minus 2 times 4 is 8, and it's equal to 4. Now I end up with a very simple linear equation here, where all I have to do is just bring the 8 all the way on this side here. And I'm going to end up then with x being equal to 4 plus 8. It ends up that x is equal to, say here, 12. All right. And that is my final result. So these two examples that I've shown you here are just examples demonstrating that sometimes the equation can already come with an equated coefficient. Now in example number 3 here now, where we're going to be getting more of an exam structure type question, this is where step 2 must be applied. So of course, I'm going to be starting off nicely here by naming my equations. And then if you pay attention close to the equation, you'll recognize that none of the coefficients are equal. So now I must apply step 2. Step 2 is I need to either make the coefficients of the y the same or make the coefficients of the x the same. Now in my previous example, you hear me mentioned that traditionally you're going to find many instructors instructing you to equalize the middle, and we're going to be sticking to that. But I'm also going to be experimenting with you in this video, showing you that also you can equalize the x. So let us start off here by equating the coefficients of the y. And so how do we actually do this? Now there's actually two ways you can do this. You can actually go ahead and find the LCM of the coefficients and then make a decision as to how you're going to get the coefficients to become that particular number. Or a shortcut method that I've taught my students for many years is that you can multiply the equations by the opposite coefficients. What do we mean by that? Well, say for example here I have a 5 here. Well, in fact it's a negative 5. I'm gonna go ahead then and multiply down here by 5, and then I'm gonna multiply up here by, say here, 3. Now, a few students may be asking the question, isn't this a negative 5? Yes, you could go ahead then and multiply down here by negative 5, but then the sign is going to automatically work out itself. So if you decide that you want to multiply down here by negative 5 and up here by 3, prepare to deal with the changes in the signs. I particularly just kind of overlook the signs and just kind of focus on the actual number here, 5 and 3, and then I pretty much use the rules of same sign subtract, different signs add, and it automatically works out itself. So then again here I'm going to be using the 5 that is up in this first equation to multiply the second equation, and the 3 that is in the second equation to multiply the first equation. Now remember that an equation must be kept balanced. So if one term is affected by a constant multiplier, then all the terms in that equation must also be affected by that constant multiplier. So yes, my focus is to get the 5 and the 3 to become the same, but at the same time, I have to balance the equation by multiplying the 3x by 3 and then minus 13 by 3. So then you look here, that 3 multiplied by 3x gives us 9x. 3 multiplied by minus 5 gives minus 15y, and 3 multiplied by minus 13 gives us minus 39, and that then therefore creates what is known as equation 3. Now I'm going to go ahead then and multiply equation 2 by 5. 5 multiplied by negative 2x is negative 10x. 5 multiplied by 3y is in fact positive 15y, and 5 multiplied by 8 is in fact equal to 40, and that is equation 4. Now, now that I have a third equation and a fourth equation, I now need to decide, should I add equation 1 to equation 2 or should I subtract equation 2 from equation 1? Well, that heavily depends on whether the signs of the equalized terms are the same or are they different. And according to the rules that we had discussed in the earlier part of the video, we definitely stated that if the signs are different, we're going to add. So we're going to add this to this here. Okay, so I'm going to like here, red. I'm going to add equation 1 to equation 2. So I'm going to add, say here, equation 1 plus equation 2. And that implies that 9 plus negative 10, that's going to give me negative x. And of course, 15, negative 15 plus the inverse of negative 15 is 0. And of course, negative 39 plus 40 is 1. So if I divide both sides by negative, of course, we have a negative x here. We must divide both sides by negative 1. Then you will find here that x then is equal to negative 1. Now, once I've obtained my value for x, I'm then going to write my statement. I'm going to be substituting, so I'm going to be subbing negative 1 for x in an equation of my choice, either equation 1 or equation 2. So I particularly, again, prefer working with small numbers. So I'm going to go ahead once again and use equation, say here, 2. So now I'm going to end up then with, say here, equation 2. So that's negative 2 multiplied by, say here, negative 1, because x is negative 1. And I'm going to have plus 3y, and that works out there to be equal to 8 according to equation 2. So carrying this information up here, negative 2 times negative 1 is 2 plus 3y equals 8. Now if I go ahead then and I transpose the 2 to the right side, I'm going to have 3y is equal to 8 take away 2. Then you have 3y is equal to 6. And then of course I'm going to be dividing both sides by 3 because I'm splitting the product between the 3 and the y. Y works out to be 6 divided by 3, which works out to be 2. And that's my final result. X is equal to negative 1, y is equal to 2. Alright, that's a nice example. Nice introduction example there. Let's apply this step then again to this example. Now again, this time we're not going to be looking at perhaps say if the signs are different. We're going to say then what if the signs are the same. So this is another chance for us to reiterate or regurgitate what we've just learned. So once again, I'm going to be calling this my equation 1. I'm going to be calling this my equation 2. So once again, I need to make a decision as to which variable do I wish to eliminate or equalize and eliminate. Again, I'm going to be sticking with my middle variable here. I'm going to be sticking with equalizing the coefficients of the y variable. So here, there's a 4 here. I'm going to multiply the bottom equation by 4. And there's a 1 that is in front of the y. I'm going to multiply the top equation by 1. Now, according to the multiplication identity, multiplying an equation by 1 does not change the equation. So therefore, equation 1 is going to still remain as equation 1 here. 3x plus 4y equal 14. And by multiplying by 1, I've just created a third equation. Now, equation 2 is going to be magnified by 4. So then 4 times minus 2x is going to be equal to minus 8x. 4 times y is in fact 4y. And 4 times 9 is 36. That becomes equation 4. And now you can safely see here that the signs, the coefficients of the middle term y are the same. And it so happens that the signs are also the same. So it differs from example number 3 that we have up here where the signs are different. So because the signs are different here, we chose to add equation 1 to equation 2. Now because the signs are the same, we're going to therefore then subtract, say here, equation 1 minus equation 2. So equation 1 minus equation 2, let me just take a red marker here and place a minus sign in between here, because you're going to find occasionally that signs are going to clash. So therefore you'll find here that 3 take away negative 8 works out to be 11x, because 3 take away negative 8 becomes 3 plus 8, which is 11x. Obviously 4y take away 4y is 0, and 14 take away 36 here works out to be negative 22. So if we therefore go ahead and divide both sides by 11 by splitting the product, you're going to find that x here works out to be negative 22 divided by 11. Therefore, x then works out to be negative 2. Now, since x is negative 2, we need to do a substitution. We therefore then need to sub negative 2 for x in, again, choose equation 1 or equation 2. Now, though I would prefer to work with equation 2 simply because the numbers are smaller, I'm going to therefore just go ahead and work with equation 1. No difference, same results. So I'm going to go ahead and put it in equation 1. So therefore I'm going to have 3 multiplied by, say here, negative 2, because it's 3x and the x is negative 2, plus 4y, that's going to be equal to 14. 3 multiplied by negative 2 is in fact negative 6, plus 4y equals 14. And again, the same equation keeps coming up. We're going to always get an equation with one variable. So here I need to isolate the y away from the 4 and the negative 6. So of course I'm going to have to move the negative 6, pardon me, over to this side of the equation. So I'm going to have here 4y equals 14 plus 6. 4y then works out to be equal to 20. And by splitting the product between the 4 and the y, we end up with y being equal to 20 divided by 4. Y works out to be 5. Alright, so 4 solid examples here. The first 2, we went through the whole concept of the coefficients of the variables that we wish to eliminate being the same. And then we went through 2 more examples here where the coefficients are different. We also therefore went ahead and looked at what if the signs are different. We're going to be adding the equations, and if the signs are the same, we subtract the equations. Remember to leave a like before you exit the video if you're getting some value already. Now, we're going to flip the script a little bit here. And as we're coming to the ending part of this video, we're going to flip the script a little bit here. And we're going to be looking at what if it's a case where you do not want to eliminate the y. What if the question asks you to eliminate the x first? Or what if the equation is set up in such a realistic way where eliminating the y will going to give you extra work? What if you just needed to just eliminate the x? We can never tell. So here I'm going to be experimenting with you and showing you that of course you can eliminate the x before the y. So same procedure, nothing will change. I'm going to go ahead then and I'm going to multiply, pardon me, I'm going to call this my equation 1 and I'm going to call this my equation 2. And so therefore then we're looking at equating the coefficients of the x. So now I'm looking here at, say here, this is a 1 right here. So I'm going to multiply the bottom equation here by 1. And then I'm going to, of course, multiply the top equation, say here, by, again, I'm going to just ignore the sign because the sign is going to work out itself based on the rules of same sign subtract, different signs add. So I'm just going to focus on the actual number right here, just the 2, and ignore the sign. If you choose to multiply the top equation by negative 2, again, prepare to deal with sign changes. And once the sign changes, if you don't change the signs, it can affect your end result. So therefore, let's go ahead and then 2 multiplied by x gives me 2x. 2 2 multiplied by negative 5y gives me negative 10y, and 2 multiplied by 2 is equal to 4. That becomes equation 3. Now, of course, according to the multiplication identity, 1 multiplied by the equation will keep the equation the same. So that becomes negative 2x plus 7y equals negative 10. And that is equation 4. Now, pay close attention to the the coefficients of the variables that you have equalized. You've equalized the coefficients of the x. And if you look carefully, that the signs are in fact different. This is a plus sign, this is a minus sign. So according to the rules, if the signs are different, we're going to add equation 1 to equation 2. So of course, when I add 2x to the inverse of 2x, I'm going to end up with 0. Negative 10 plus 7, this works itself out to be negative 3y. And 4 plus negative 10 works itself out to be negative 6. So if we split the product between minus 3 and y, we're going to end up with y being equal to negative 6 divided by negative 3. Therefore, y works out to be positive 2. Now that y has worked itself out to be equal to 2, I'm therefore then going to do a substitution. I'm going to sub 2 for y in equation, say here, I have to make a decision. I want to use equation 1. Numbers are really small. 1, negative 5, 2, as opposed to working with negative 2, 7, and negative 10. So I'm going to go ahead and use equation 1. So I'm going to go ahead then and say here, since y is in fact, say here, 2, I'm going to have x take away 5 multiplied by the value of y, which is 2, and that's going to be equal to 2. So then x take away 10 is equal to 2, and then very simply then transpose negative 10. I'm going to therefore then get x is equal to 2 plus 10. X therefore then works out to be equal to 12. So x is 12 and y is 2. Alright? And that is pretty much, of course, how to solve that equation. Now, as I promised you guys at the end of the video, I'm going to be pushing the bounds of simultaneous equation. Now, for CSEC secondary students, you're most likely going to find examples like these in your textbooks. But for the purpose of exams, we have already comprehensively covered all the situations that you can encounter on an exam. Of course, for this particular example that you're looking at on screen at the moment, and of course, I'm going to be walking you through yet again another worded example. After these two, you should comprehensively understand what simultaneous equation is all about and how to resolve them. Now again, this equation is not traditional, okay, where you have a fraction as your coefficient. And so here, there's a couple of ways to actually approach this question, but I'm going to be using the easiest method. Now, we're not very accustomed to having to make the coefficient, say here, of an equation a fraction. We're not accustomed to having the coefficient a fraction. So what we can do is that we can kind of fix this equation up a little bit. Let me just go ahead then and rewrite my first equation. My first equation is already in its usual form, 3x minus 5y equal minus 16. But the second equation needs a little bit of fixing. So if we remembered a concept that I had taught in one of my previous videos, we said that if the denominators are in fact different, we can therefore then go ahead and multiply the whole entire equation by the LCM. So I can fix equation 2. So let's write fix equation 2, because this is equation 1, this is equation 2. So fixing equation 2, so fix equation 2, the LCM here is 15, 3 and 5. So I'm going to have 5 multiplied by a third x plus 5 multiplied by 2/5 y and that's equal to 5 multiplied by 3. To fix this equation, pardon me, it's not 5, pardon me, it's 15. So 15 is the LCM, so 15, 15, 15. Pardon me, guys. So now by multiplying all of the equation by 15, the 3 cancels here, leaves us with 5. The 5 cancels here, multiplies here by 3, and then 15 times 3 is 45. So this equation has now been adjusted to being 5 times x is in fact 5x. 3 times y is in fact, 3 times 2y is in fact 6y. And 15 times 3 is in fact 45. So then this now is my fixed equation number 2. So then I can go ahead and align myself here. 3x minus 5y equal minus 16. And 5x plus 6y equal 45. Alright? And there's other ways to do this. Of course, if you're really good at math, then you can actually go ahead then and you can actually multiply this equation here by 25. And then you can multiply equation 1 by 2. So therefore, you'd end up getting 10 in front of the y's. That's a little bit challenging. That's a bit too much thinking for a question like this. You can actually make it simpler by using this method. So therefore, you can go ahead then and simplify this equation then. So we know we're going to go ahead then and we're going to say equation 1 and equation 2. Alright, so we can go ahead then and choose to equalize the x or the y. I'm going to stick with the y's as usual. I'm going to multiply this here by 6. And I'm going to multiply this equation here by 5 because the LCM of 5 and 6 is 30. So 6 times 3 is in fact 18x. 6 times minus 5y is in fact 30y. And 6 multiplied by 16, that's going to give me minus 96. 5 multiplied by 5x is 25x. 5 multiplied by 6 is 30. So that's positive 30y. And 5 multiplied by 45, that's going to be 225. So therefore then, if we go ahead then and add both equations, then you're going to find that 18 plus 25 is 43 x. The signs are different, so that's why we're adding. So let me just add my addition sign in between here. So I'm going to be adding. If we add negative 30 to its inverse, it becomes 0. And if we add minus 96 plus 225, we end up, say here, with 129. And if we therefore then go ahead and divide both sides by 43, you're going to find that x then is equal to 129 divided by 43. It therefore then works out that x is equal to 3. So I'm going to go ahead then and I'm going to sub 3 4x in. Of course, I'm not going to be using equation 2. I'm just going to definitely go ahead and use equation 1. So that means I'm going to have 3 multiplied by 3, because that's x right here. 3x, 3 times 1, 3 times 3, pardon me, minus 5y is equal to minus 16. So this is 9, take away 5y is equal to minus 16. Transpose the 9 to the right side. I'm going to end up with negative 5y equals negative 16 minus 9. That's going to give me negative 5y is equal to negative 25. And then easily then if I split the product between minus 5y, minus 5 and y, I'm going to end up with y being equal to negative 25 divided by negative 5. Y is equal to 5. And that sorts out that equation. Alright? So, probably the most challenging equation that you're going to get at the secondary level. Not very common, but it's possible. So you want to be prepared for all situations then. And then of course, finally then, I want to bring you into the worded aspect. Now I do have some examples that I want you to take a screenshot at the end of this video. So you can go ahead now and pause the video. And after I explain how you actually work out these worded questions, you can actually go ahead and work these questions out here and leave your solutions in the comment section. I'll respond to you if it is that you have gotten these questions correct. All right, so take a screenshot of what this is and work them out. These were taken from a textbook that I'm currently using with my secondary level students. So you can actually attempt these and leave your suggestions, your questions, your answers in the comments. Let's attack this question here. At a grocery store, 7 packs of milk and 9 bottles of water cost $31.50, while 13 packs of milk and 6 bottles of water cost $39.75. Our task is to use M to represent the cost in dollars of 1 packet of milk or 1 pack of milk, and W to represent the cost in dollars of 1 bottle of water. Write a pair of simultaneous equations to represent the information above, and of course, hence determine the cost of a pack of milk and a bottle of water. So this is a more real life application question of the topic of simultaneous equation. So we're going to start off by, of course, writing down the equation. We are first told to use, say here, M to represent milk, and we use W to represent water. So already I know that 7M, that's 7 pack of milk plus 9 bottles of water will equate itself to being equal to $31.50. And then of course we have, say here, 13 packs of milk. So that's 13M added to 6 bottles of water, that's 6W. That equates itself to being $39.75. And so we've just created our equations by reading the information. And that's it. That is how you create the equations, right? Most times when it's a worded questions, most times it's a plus equation. Now to wrap this up then, we're going to of course go ahead and find the value of a cost of pack of milk and a bottle of water. In other words, they're basically asking you to find the value of M and find the value of W. So same procedure, nothing changes. Call this equation 1, call this equation 2. Of course, I'm going to try to make the smallest coefficients the same. So 9 and 6, I'm going to be using, say here, I'm going to try to make both of these numbers become, say here, 18. All right, so the LCM of 9 and 6 is 18. I'm going to go ahead and multiply this by 2. And I'm going to multiply this here by 3. Now, if you wanted to, you could multiply the top equation by 6 and multiply the bottom equation by 9. You're going to end up with bigger numbers, but that's fine. If that's the way you want to do it, no problem. But then I tend to always try to use small numbers. So 9 and 6 LCM is 18. I try to figure out what do I do to the 9 to let it become 18, and what do I do to the 6W to let it become also 18. So I'm therefore going to go ahead and multiply all by 2 and all by 3. So 2 times 7M is in fact equal to 14M. 2 times 9W is 18W. And 2 times $31.50 is in fact equal to $63. That is equation 3. 3 times 13M is 39M. 3 times 6W is 18W. And of course 3 multiplied by 39.75, that's equal to 119.25. That becomes equation 4. So therefore then, the signs are the same for the middle terms. So I'm going to subtract, and subtract. So 14 take away 39, that's going to be equal to negative 25. 18 take away 18 is 0. And of course, 63 take away 119.25 going to end up with negative 56.25. So if I divide both sides by negative 25 to split the product, you're going to find here that negative 25 m divided by negative 25 is equal to negative 56.25 divided by negative 25. Remember, this is money, so it's always going to be a positive value. So that's going to be divided by 25, negative 25. We're going to end up with m being equal to $2.25. And since m is equal to $2.25, that means that a pack of milk costs $2.25. Now we can go ahead then and do a substitution. So we're going to be substituting then. So we're going to sub 2.25 for m in equation of my choice. I'm going to tend to use the smallest one, which is in this case here, equation 1. So I'm going to go ahead then, I'm going to substitute 2.25 for m. So that's going to be 7 multiplied by 2.25 plus 9w equal 3150. 7 multiplied by 2.25, that works out to be 15.75 plus 9w equals 3150. Transfer this information here. I'm going to then subtract 15.75 from both sides. So I'm going to end up with 9w is equal to, when I subtract 15.75 from 3150, 15.75, double check, I actually get 15.75. And so therefore then 15.75 minus 9, sorry, not minus 9, pardon me, 15.75 divided by 9, I end up with a bottle of water being equal to $1.75. And that is equal to, say here, W. Alright, so this was in fact, I believe, in my opinion, a very elaborate and thorough video that covered, in my opinion, all the possible scenarios that you can actually encounter when it comes to exam questions. If you definitely want more practice, I have a link here to which you can copy. Well, I don't think you can copy it from the video, but I'm going to pin it in the comment section and also in the video description. You're going to copy this. This is in fact a beautiful worksheet from Corbett Math, posted on 2019, the 5th of the 9th, or the 9th of the 5th, I think. All right, and it's a practice worksheet. I think I did a video on this on my previous math channel when I just started YouTube, but that video was done to my satisfaction, so I kind of left it out there in the open. But this worksheet here, I will also pin a link to that older video that I had done on this whole entire worksheet. What you can do is that you can attempt some of the questions here as practice and then go over to that video and watch to see if the solutions that you have matches mine, or you can just leave it in the comment section below and type the question and I'll work it out for you and respond to you if your answer is correct. All right, so engage with me in the comment section, guys. I'd love to hear from some of you guys if this video has helped you to improve, and if it has, of course, please go ahead and leave a like, leave your thoughts in the comment section, and of course, do not forget to subscribe. So until next time, guys, thank you so much. In part 2, we're going to be diving into the substitution method, and I'm going to be seeing that video in a couple of days from now. So until then, take care, keep on practicing, guys, and get prepared for your exams coming up. All the best, take care, bye bye.